The second part of section 2 is called log equations, and we're going to be working on a few of these. What you do first is you always take your equation, you write it in exponential form, and then you solve for a variable. So you're being given some problem in exponential form, and you're going to take that and solve for your variable. First, you always write in x, we solve, and we just reviewed exponent form. So if I have log base 4 of n equals 5 over 2, I'm asking myself, 4 to what power will give me n? Well, 4 to the 5th over 2 will equal n. So I write it like this, 5 over 2 equals n. How do we solve this? Well, we can put it into our calculators. You can do 4 to the power of 5 over 2, or you can get rid of that 2 by making 4 a power, have a power with 2. And so I can say 2 squared over 5 over 2. That would cancel my 2's. And then I get 2 to the 5th equals n, or simply 32 equals n. If I plug that back into my logarithm problem, it would say 4 to the power of 5 over 2 would equal 32. And that's just solving logarithm equations. You always want to write them in exponential form. And then from there, you want to go solve for a variable. Let's try one more of those. If I have log 8n equals 4/3, I'm going to write that down as n equals 8 to the 4/3, or n equals 2 to the 3rd over 4/3. We cancel off those 3's. N equals 2 to the 4th, or n equals 16. Write in exponential form and solve. We're also going to briefly review just two easy cheesy properties of logs. Well, one easy cheesy property of a log. And it's just that if our bases are the same, we can set things equal to each other. For instance, if I have log ax equals log ay, my bases of my logs, a and a are the same. That means that x and y are equal to each other. If I have log 7 to the 4 equals log 7 to the x, if I said solve for x, you say, wait, these bases are the same. So then I can just take whatever my log is a log of, and I can say 4 equals x. So x here is simply 4. Let's try another a little bit longer. Log 5 p squared minus 2 equals log 5p. Look, if you notice here, we have the same base 5. Sorry, someone's coming in the house. You're all good. It's all good. I'm laughing. That's fine. Log 5p squared minus 2, log 5p. So I just set these two equal to each other. I have the same logarithmic bases, and I can set each of whatever my log is talking about equal to each other. So I can say p squared minus 2 equals p. P squared minus 2 equals p. If I rearrange this, we have a quadratic. P squared minus p minus 2 equals 0. Minus 2 plus 1 equals 0. All we need to know is that if you have the same basis, then you can set these numbers equal to each other. This is on page 534, section 2.